Hello, everyone, and welcome back to Part 3 of our ISTQB Mobile Application Testing Exam Series, where we will encounter questions from 11 to 20. Part 1 has all the exam questions, and in Part 2, we broke down questions 1 to 10. You'll find the links in the description below, so be sure to check those out if you haven't already. Now, before we dive into question 11, make sure you're subscribed to our channel, One Run Academy, so you don't miss any of the software-related content coming your way. All right, let's now take a look at question number 11. Which of the following is an example of a tester performing a test related to mobile device input sensors? A. Testing that no UI elements overlap, especially on smaller screen sizes. B. Testing if an app looks user-friendly when in landscape mode. C. Testing if the device screen's maximum brightness is within safe limits. D. Testing the device screen's auto-rotation when tilting the phone. So, let's go through each option to understand which one involves testing mobile device input sensors. First, we have option A, testing that no UI elements overlap, especially on smaller screen sizes. Well, I would say no to this one. You see, this is primarily a UI test. The tester is focusing on the layout and visual arrangement of UI elements, ensuring they don't overlap on smaller screens. This doesn't involve any input from mobile device sensors, so option A is far from being relevant. Next is option B, testing if an app looks user-friendly when in landscape mode. This scenario falls under user acceptance testing and UI testing. Here, the tester is checking the visual and usability aspects of the app when the device is in landscape orientation. It doesn't involve any sensor data evaluation, making option B also not related to mobile input sensors. Then, we have option C, testing if the device screen's maximum brightness is within safe limits. I believe this one is more of a compliance with industry standards for screen brightness to ensure it's safe for users' eyes. It doesn't involve testing any of the mobile device's sensors, making option C an incorrect option. Finally, we have option D, testing the device screen's auto-rotation when tilting the phone. Now, this one should be the correct answer, or our previous analysis could be all wrong. And thankfully, it is correct. As you may have noticed, this test directly involves mobile device motion sensors, such as the gyroscope and accelerometer. These sensors detect the tilt and send signals to the system to switch the screen orientation from portrait to landscape or vice versa. Therefore, this test is directly related to mobile device input sensors. So, the correct answer to this question is option D, testing the device screen's auto-rotation when tilting the phone. Great. Let's discuss the next question, which is number 12, and it says, you're testing some mobile device input methods. Which of the following options is the least related to your task? A. Switching between finger touches and stylus to navigate the system. Switching between GPS and Wi-Fi to get location coordinates. C. Testing Siri's voice commands accuracy in noisy conditions. D. Scanning a QR code to verify it corresponds to the exact expected outcome. Okay? A straightforward question here, and let's analyze each option to determine which one is not so much related to testing mobile device input methods. Starting with option A, switching between finger touches and a stylus to navigate the system. I believe this one is directly related to input methods, as it involves evaluating how the app responds to different types of touch inputs. Finger touches and stylus inputs are both common methods for the user to interact with a mobile device. So option A is definitely related to mobile input testing. Now, option B states that switching between GPS and Wi-Fi to get location coordinates is a test related to the mobile drive input method. Well, I don't think so. While GPS and Wi-Fi are both used to determine location, they do not qualify as input methods in the context we are discussing. Input methods involve the user directly providing input to the device, like touch or voice. Here, the location data is passively retrieved from satellites or Wi-Fi networks without direct user interaction. Thus, option B is the least related to testing input methods. Perfect. I guess there's no harm in looking at the remaining options. And let's start with option C, testing Siri's voice commands accuracy in noisy conditions. Sure, this involves using the device's microphone to receive voice inputs and evaluate the performance of voice commands under various conditions. Since it directly deals with voice input, this is clearly related to mobile input testing. And lastly, option D, scanning a QR code to verify it corresponds to the exact expected outcome. This option involves using the device's camera to capture and interpret QR codes, which is another form of input. Therefore, this is also related to mobile input testing. This takes us to the conclusion that the correct answer to this question is option B, switching between GPS and Wi-Fi to get location coordinates, which is the least considered as an activity relevant to testing mobile device input methods. Next, question number 13. Which of the following options is the most accurate? A. During orientation change, output data is kept, while the input fields should be wiped blank. B. Apps supporting orientation changes are typically native and hybrid apps, while web applications do not support this feature. C. The app's UI does not just look different when changing orientation. Different functionality and UI elements may appear. D. To save money and time, one test is sufficient to verify the app's correct behavior when changing orientation. Cool. Let's break down each option and try to find out the most accurate statement, which should be an easy task. Starting with option A, which says, during orientation change, output data is kept, while the input fields should be wiped blank. Immediately, this option is recognized as incorrect. This is because in order to provide a better user experience, it is crucial that all data maintains its integrity during orientation changes. This means that both output data, such as a video playing, and input data, such as text in text fields, should remain intact and not get corrupted, erased, or altered when the orientation changes. Now, moving to option B. Apps supporting orientation changes are typically native and hybrid apps, while web applications do not support this feature. This statement is also incorrect, as both native and hybrid apps may or may not support screen orientation changes. This is depending on their design and specific requirements. For example, a native video app like YouTube supports orientation changes, allowing users to rotate the screen for full-screen viewing. On the other hand, some native apps like Instagram's main feed lock the orientation to portrait mode only. Meanwhile, web applications are displayed through mobile browsers, which generally support orientation changes by default. So, when a user rotates the device, web apps can automatically adjust their layout to fit the new orientation, regardless of app type. Next, option C. The app's UI does not just look different when changing orientation. Different functionality and UI elements may appear. I believe this option is correct. Why? Simply because when the screen orientation changes, the system discards the current UI elements to save memory and redraws a new interface in the new orientation. It adjusts the layouts, dimensions, and elements to fit the new orientation, which often results in a different-looking UI appearance. Additionally, some UI elements or functionalities may appear or disappear with the orientation change. For example, a calculator app might display a basic calculator in portrait mode, but switch to a scientific calculator in landscape mode. Finally, option D. To save money and time, one test is sufficient to verify the app's correct behavior when changing orientation. Again, this option is not correct. Testing for device orientation changes requires several tests, not just one. For instance, you need to test the app with data, without data, in different states while loading, etc. This ensures that the app handles orientation changes correctly in various scenarios. So, the most accurate option is C. The app's UI does not just look different when changing orientation. Different functionality and UI elements may appear. All right, let's go through question number 14, which says, your mobile app, which is an email client, has received a lot of complaints that it freezes when a high number of emails get received in a very short period of time. Which of the following use cases might trigger the same problem and can help you replicate the issue? A. Connecting the device to the charger overnight. B. Setting the device on airplane mode overnight. C. Disconnecting Bluetooth overnight. D. Putting the device on the silent overnight. So, this question states that your email client mobile app has received numerous complaints from users reporting that the app freezes whenever a flood of mails are received in a short period of time. This is a serious performance issue that needs to be fixed. Now, in this situation, your goal is to replicate this freezing problem during your testing so that the developers can properly identify the cause and implement a solution. In testing terms, we're looking for use cases, specific scenarios where the app behaves in a way that could trigger this issue. So, we must think about situations where the app has to handle a high volume of incoming data or perform similarly demanding tasks. We want to see which of these use cases could trigger the app to behave in the same problematic way, helping us pinpoint the root of the issue. Now, what could be the best option? Surely, it's option B. It resembles a scenario that will cause an overflow of notifications to be received at once. Setting the device to airplane mode overnight will prevent any incoming emails until airplane mode is turned off in the morning. When airplane mode is disabled, a surge of emails and notifications will be received all at once. This can cause slowness or app freezing. Thus, this situation can replicate the issue, allowing you to verify it and report it to the development team. The remaining options actually have no impact on receiving emails and their notifications. For option A, it is very obvious that charging does not influence the sync capabilities of the app. For option C, it's no-brainer that emails are received via Wi-Fi or cellular data, but not Bluetooth. And finally, option D also has no impact on receiving emails or notifications. And the only noticeable effect is that these notifications will be silenced. Thus, the correct answer to this question is option B. Awesome! We're about to hit the halfway point in this video, as we're going to encounter question number 15. If you're enjoying the content so far, do us a favor and smash that thumbs up button. It really helps get this video in front of more people who are passionate about ISTQB mobile app testing, just like you. All right, let's get back to business with question 15, which says, you are reviewing the requirements for a mobile video recording app with the development team. The requirements specify that the app needs two main permissions: camera access for recording video and microphone access for recording audio. Your team is now discussing a use case where the user grants the camera permission but denies the microphone permission. What is your best suggestion for how the app should behave in this situation? A. The app should not be able to record anything unless all the required permissions are granted. B. The app should override the denied permission and record audio and video. C. The app should be able to record video without audio and notify the user about that. D. The app should not allow the user to open the app unless all required permissions are granted. Great! Let's quickly encounter these options and see which of them is the correct one. First, option A. This one is clearly not correct. The user experience would suffer because the user might have intentionally disabled microphone access for a specific reason. For instance, the user might plan to edit the video later and add their own music or audio. Restricting the app's functionality entirely due to one denied permission is not user-friendly and could frustrate users. Next, option B. Also, it's not correct. This approach would be a major issue and could lead to the app being banned and removed from the App Store for violating the user's privacy. Apps must respect user permissions and cannot override denied permissions without user consent. This would breach user trust and violate App Store guidelines. Next, option C. This option actually seems very good. Respecting the user's choice is the best approach. The app should gracefully notify the user that audio will not be recorded and advise them to grant microphone permissions if they want to include audio with their video. This approach maintains the functionality of the app while respecting user privacy and choices, providing a clear and understandable message to the user. Option D is very similar to option A, and it's a poor choice. The app might have other features like video editing or sharing. So, preventing the user from launching the app due to a denied permission can make the user suspicious about why the app is pushing them so hard to accept all permissions. This could lead to user frustration, uninstallation of the app, and negative reviews. It is important to ensure that the app can still provide value and functionality, even if some permissions are denied. So I think we all can agree that option C is the most reasonable choice in this context. All right, let's encounter question number 16. As a test manager, you invited a group of random regular users to participate in UAT or user acceptance testing to evaluate the notification functionality of your upcoming email client mobile application. The following findings were reported by the participants. Which of them should you consider the most? A. Long pressing on an email from the notification bar and then tapping delete email does not actually delete it. B. The app notifications are showing, but with some delay when the phone's battery is under 10%. C. Notifications show up only when the device is connected to the internet through Wi-Fi or cellular data. D. When the phone is set to silent, upcoming notifications are displayed, but with no sound. Select one option. A very straightforward question, I must say. And I believe that we can all agree that option A is the correct answer here. Simply because if interacting with a notification does not perform the expected action within the app, this would be considered a major issue. This could frustrate users who think they've deleted an email, only to find it still in their inbox later. It sabotages the app's reliability and user trust, making this the most critical finding to address. Moving to option B. I would say that this one is not a major issue that requires our top priority, as when the device battery is low, the operating system often limits background activities, including sync operations, to conserve power, of course. Users generally understand and accept this behavior, as they prefer to preserve battery life over immediate notifications. This makes option B not as strong in rationale as option A, so let's forget about it. Now for option C, this is also not the correct answer. Since this is an email client, it is expected that notifications are dependent on an internet connection. Without internet access, the app cannot retrieve new emails, so it is reasonable for notifications to only appear when the device is online. And lastly, option D is again not correct. Respecting the device's silent mode is expected behavior for most apps, especially non-critical ones like an email client. Users set their phones to silent to avoid interruptions, so the app should not override this setting. Silent notifications are appropriate and expected in this scenario. So, to summarize, the most important issue to address is option A. Long pressing on an email from the notification bar and then tapping delete email does not actually delete it. This is a functional failure that directly impacts user experience and trust in the app's core functionality. Very well. Let's move quickly to question 17, which says, you are assigned the task of checking the quick access link feature of a stock trading app. Which of the following is the least relevant task? A. Verifying that quick access links appear upon long tapping the app's icon on iOS devices. B. Verifying that interacting with an app icon through 3D Touch in Android will trigger the quick access links menu. C. Verifying that the app works without crashing if installed on older Android versions that do not support quick access links. D. verifying that actions taken on iOS devices through quick access links are actually reflected within the app. Excellent. I believe you can see that all these options are actually relevant to any testing task related to quick access links. However, and if you look closely, option B contains one blunder. Option B stated that the verification process in Android requires triggering the quick access links menu through 3D touch. This is the incorrect piece of information, as in Android, this is called app shortcuts and not 3D touch, which is relevant to iOS. Thus, making option B not entirely correct, and this makes it the answer to this question. All right, guys, let's shift our focus to question number 18, which says, a tester is considering how to test a new version of a navigation app. Some of the app's documented requirements are: the app is designed exclusively for Apple smartphones. App implementation uses Apple SDK and Swift programming language. App's top priority is responsiveness and high performance. The app will use GPS, Wi-Fi, cellular, and accelerometer features of the device. Which of the following tests should have the most priority for such an app? A. Cross-browser compatibility, to ensure the app is compatible with different browsers. B. Usability testing, to ensure the look and feel of the app against the platform's guidelines. C. Performance testing, to ensure the native wrapper is not causing any performance bottlenecks. D. Device compatibility, to ensure smooth app usage across the most used devices in the market. I hope you've noticed that the key to answering this question is identifying the type of app we're dealing with. The documented requirements clearly show that this is a native app, and here's why. 1. Exclusively for Apple smartphones. This indicates it's specifically designed for iOS devices, making it a native app. 2. Apple SDK and Swift. These are tools and programming languages used to create native iOS applications. 3. High performance and responsiveness. Native apps are known for their superior performance due to direct access to device resources. 4. Utilizing device features. Accessing features like GPS, Wi-Fi, cellular, and accelerometer is common for native and hybrid apps. So, do we all agree that this app is a native app? Great. Now, from this point, things are going to be much easier, and we can begin discussing the options to select the correct one. Starting with option A, cross-browser compatibility. This one is totally incorrect. Native apps do not require web browsers to operate. They run directly on the device's operating system. Therefore, cross-browser compatibility is not relevant for a native app. Moving next to option B, usability testing. This one is also not correct. While usability testing is important, the context here is a new version of an already existing app. This implies that the app has already been through usability testing and has been in use. So it seems that it's not that important. However, let's keep this option in mind, just in case. Now, option C, performance testing because of possible wrapper's bottleneck. So, wrapper, huh? Well, unless we're talking about burritos, I think we can leave the wrapping to the hybrid apps. Native apps do not require wrappers to operate, and this is more related to hybrid apps. So yeah, no performance bottlenecks caused by any delicious tortilla-like layers here. And finally, let's encounter the last option, option D, device compatibility. Yes, this is exactly what we need to do. This is because new app versions may introduce new features that need to be tested across various devices to ensure compatibility. Additionally, some new devices may have appeared since the last app update, and we need to verify our app working seamlessly with these new devices with their new features and hardware components. So, I think it's pretty obvious by now. Option D is the most accurate option, and we can accept it as the correct answer to this question. Moving next to question 19. And as always, let's start by reading the question and its options together. Consider two tech companies developing native mobile apps. Company X develops mobile apps for Android and iOS using cross-platform technologies. whereas company Y develops mobile apps for the same two platforms but using native SDK technologies. Which of the following statements is least correct? A. Android and iOS apps developed by company X will have a lot of shared code if compared to apps developed by company Y. B. Apps developed by company X will require less total testing effort if compared to apps developed by company Y. C. Both apps developed by company X and Y do not suffer performance issues related to the native wrapper. D. Apps developed by company X usually cost more if compared to apps developed by company Y. Very well. Before we discuss the available options, let's make sure that everyone is clear on the scenario. We're comparing two tech companies, Company X and Company Y, that develop native mobile apps but use different technologies. Company X uses cross-platform technologies to develop apps for both Android and iOS. This means they write much of the app's code once, and it runs on both platforms. And then we have Company Y, which uses native SDK technologies, meaning they write separate code for Android and iOS apps using the respective native development tools and languages. The question asks us to identify the statement that is the least correct regarding these two companies. From this point, we can start tackling each option. Let's start with option A, which is a true statement, by the way. So when an Android and iOS app are developed using cross-platform technology, they share a lot of the same code. However, when these apps are developed using native SDK technologies, each app is implemented separately with its own unique codebase. So option A is not what we're looking for. Moving to option B. Testing apps developed with cross-platform technologies indeed requires less effort compared to apps developed with native SDK technologies. This is a 100% true statement. This is because cross-platform apps share much of the functional code between versions. Therefore, you can perform functional testing on one version, for example iOS, and expect the results to be similar to the Android version. In contrast, native SDK apps have separate code bases for each platform, requiring independent testing for each version. Moving next to option C, this statement is also a true statement. Apps developed using cross-platform technologies or native SDK technologies are ultimately native apps. They do not use the native wrapper that hybrid apps rely on. Therefore, they do not suffer from the performance issues related to native wrappers. Finally, it's time for the last option, option D, which should be the incorrect statement. And indeed, it is. Apps developed using cross-platform technologies are very cost-effective because multiple versions of the app can be developed simultaneously, sharing most of their functional code. This significantly reduces costs compared to native SDK apps, where each version has to be developed from scratch. Therefore, the correct answer to this question is option D. All right, everyone. I think it's time now to take a look at the last question of this video, which is question number 20, and see if we can get this one right. The question says, you received complaints about your fitness app not registering accurate activity data. Most complaints are from users with power-saving apps installed. You will perform RCA to understand the underlying issue. Which task are you likely to perform? As usual, 4 options are provided. A. Testing for backward compatibility with OS versions. B. Testing for interoperability with other apps. C. Testing for different mobile app types. D. Testing for device input sensors and methods. So, before we continue with this one, let's make sure we understand the question and that everything is clear in the scenario. So, a fitness app that seems to work well except for some complaints from users who installed battery-saving apps on the same device. Therefore, we can suspect that the issue is mostly related to the existence of both the fitness app and any battery-saving app side by side. Perfect. Let's now go through each option to understand why it is correct or not. For option A, we can see that there is nothing in the question indicating that the fitness app is having issues with specific OS versions. The issue reported is related to the app not registering accurate activity data due to power-saving apps, not due to compatibility with different OS versions. So this option is probably not the correct one. Now, when we move on to option B, we can see that it is the most relevant task. Why? Because power-saving apps may turn off GPS and other important sensors required for the fitness app to operate accurately. The solution? Testing for interoperability with other apps will help identify if the power-saving apps are causing conflicts by disabling necessary sensors or services that the fitness app relies on. Therefore, we will consider option B the correct answer to this question, for now. Next, option C seems incorrect. Testing different mobile app types, whether native, hybrid, or web-based, is irrelevant in this case. The fitness app seems to function properly on its own, but issues arise when it coexists with power-saving apps on the same device. The type of app is not the focus here. The same can be applied to option D. Testing for device input sensors is not the main concern. The input sensors are not the issue since they seem to work well under typical conditions. The problem arises when other apps, specifically power-saving apps, interact with the fitness app. Additionally, input methods, such as keyboards and gestures, are not related to this issue. Therefore, we can confirm that option B, testing for interoperability with other apps, is the correct answer to this question. All right, that's all for this video. Stay tuned for the next one in which we will encounter the next 10 questions from number 21 to 30. So until the next video, take care.